What? No. No, Mom, your computer doesn't have COVID-19. I know it's a virus, but your computer can't get it.
Welcome to the show. I have Ryan Berry with me today. Ryan, what's up?
Not much. How's it going today?
I
Strange
see
times.
I see you're hunkering down in an underground bunker.
I am. Yeah. I went down to NORAD and where the Whopper's housed, and I'm sitting down there making sure it's we keep the lights on.
Yeah. Yeah, cool. Well, I mean, I'm really impressed with the quality of our connection because I'm up at Moonbase Alpha and
That's
the
some
network
incredible latency.
connectivity.
Yeah.
Yeah, the network connectivity seems to be great.
Yeah. Yeah. Nice.
So I was kind of talking to you a little bit today about what it is that I wanted to accomplish. And so one of the things that I want to accomplish today is I want to, and by the way, guys, we're going to surprise Ryan with this as well a little bit. I told him generally what we were going to do, but because we have time today and because we're all sequestered in our bunkers and on the moon, I figured why not? What the heck? Let's do it like this. So, are you ready?
I'm ready. Let's go.
Here is the network that I want to create. And this part is kind of easy, right?
Yep.
We're just going to go into Azure. We want to create a couple of subnets.
hmm
And so the fun part is going to be defining network connectivity to the boxes that we create. We're going to create a couple of VMs up here in these subnets.
hmm
And so defining network connectivity to those boxes via VPN that connects to my network. And we want to do it step by step so that everybody could watch this video, understand step 1, do this, step 2, do this, step 3, do this, step 4, do this. Sound
Yep.
good?
Sounds good.
All right, I'm going to make you full screen again. Hang on. I'm going to really make you full screen. Okay, there we go.
All right.
So kick it off, man. What do we need to do
Yeah.
first?
So, and Azure has a plethora of, of vehicles that you can use to connect services together within the cloud and also outside of the cloud, which is often, a requirement when customers have stuff on premises that they want to plumb in. So, one, that to start off with, we can talk quickly because it's easier to demonstrate and also to walk through the options that exist in in Azure, is to have multiple networks in Azure. So why would you need to do that? So let's think about a scenario where a customer might have maybe Palo Alto devices that are scanning network traffic, and they want to put that in like a centralized place sitting in Azure and actually have all outbound traffic to the internet going through their appliance. Or maybe they want to be able to use that sort of device as a way to to control ACLs and network security to different networks, both on premises and in the cloud. Another reason why you might want to have multiple networks in Azure is maybe you have stuff in two different regions,
Right.
in the East US, West US. So there's one easy solution that is available in all clouds is just simply setting up a VPN tunnel between those networks. The challenge with that, and actually that's actually the only way that some of our competitors offer to be able to do this sort of thing. The challenge with that is that you're limited with throughput. So if you have, if you use the inbuilt features in Azure, then you can get up to like 1.5 gigs of network throughput. Or if you buy, like a Barracuda appliance, you license it based on the amount of traffic that you want to push through that. So in both of those scenarios, you're going to be, the choke point is going to be your virtual appliance, the box that you establish those IPsec tunnels on. So in Azure, we've taken that a step farther. We have this massive global network that we've defined and invested billions in building out, and customers can actually string a virtual patch cable between those networks, and you're not limited by throughput between those networks. So if you're across regions, maybe have a network in Europe and Asia and one in the US, you can string all those together, and your limiting factor is the speed of light, and we don't really have any advertised limits of how much throughput or bandwidth we provide, but it, you know, I've seen, you know, demonstrations where you can get tens of gigabits of throughput between those links.
Wow. So
Yeah.
now is that between just links that exist in Azure?
Yes, yeah. So
Yeah.
so now we're covering the top part of your diagram there, where you have multiple
Right.
networks, you know, different regions maybe, or even maybe in the same region where you might have like an IT lockdown network with that Palo Alto example, and then one that other services are deployed onto, or maybe multiple networks of services, kind of a hub and spoke design, which is a common
Yeah.
thing that a lot of customers I work with need.
Okay. So let's go ahead and set up the top part of that network. How does that sound?
Sure, yeah. Let's go ahead and let me flip over here. So I have my my Skynet network. That's actually where I have everything set up. But what we can do is maybe start with an example, you know, because the peering is actually easy to set up. That's actually the technical feature in Azure. It's called VNet peering, where you can actually tunnel those two things, two networks in Azure together. So
Okay.
I'm just going to go ahead and flip my subscription, and we'll call it Taste. And I will. What I'm doing is creating a resource group, kind of the container to
Right.
house all the
Yeah.
stuff.
Yeah.
So I'm going to go ahead
And
and
the
just.
subnets can be in the same region. I don't really care.
Yeah, okay.
Yeah. Yeah. I just want to make sure that everybody understands how to get from their local environment to the cloud, so that it's a seamless network.
Okay. So.
By the way, I don't know if you noticed, but I started dyeing my beard gray.
Well, you look much more distinguished.
Yeah.
Uh,
It's a lot of work.
yeah, yeah.
You know, I got to put all this together every day, and it's just a lot of work.
All right. So what I'm going to do is I'm going to go ahead and create a virtual network.
Yep.
All right. All right. And I believe I put this, there it is. Okay. So it's going to default because, so this is actually an important thing that that some of the viewers might not know about. So when you create a resource group, you can have stuff inside that resource group that resides in other places. So even though the resource group has a home in East US, I can put a network in here in Asia or Europe.
Right.
It's
right.
so
Yeah, that's a good point.
Yeah. So we'll go ahead and make this
And like you said, connectivity is just as fast.
correct. Yep.
Yeah.
So we'll go ahead and go into the IP addresses. So this is going to be a 172. Do you have any favorite numbers that you want to make this?
Yeah. Let's make it 10.10.10.0/ and then we can do a 15 if you want.
15. Okay.
Yeah.
All right.
Oh wait, that's for the network, right?
Yeah, this is the address space. So
yeah. So do a 24 actually, since it doesn't matter. You can delete the third 10 and let's just make it a class B.
Yeah.
Or I guess it's still a class A
yeah.
IP address range, but we'll make it a class B for this
Correct.
for this network. Yeah.
Yep. And you see we support IPv6, and we'll go ahead and add a subnet to this guy just to actually have something.
Okay. So subnet A is going to be 10.10.10.1/ whatever you want. You could do 15 if you wanted.
Yeah. Okay.
Okay.
Whoops.
Yeah. There we go.
Is that not in the range?
Yeah. So 10.10.0/15, right?
10.10.10.0. What are we doing?
No. Just the third octet. Make it a 0.
Yeah. Okay. It is not in the address space that we're in.
Oh well, we're just looking silly.
Yeah, we are.
Okay. Nah, that's not gonna work.
Yeah.
Okay.
16. I mean, I guess I'm obviously my CIDR math is failing me here on the. Let's see. Let's go ahead and try this again here, just to. I thought there was actually going to be a default that we could actually run with.
Yeah, you could probably just add a default, and then we can create the subnet range
Yeah.
for the second one.
Yeah. Yeah, so we actually do need a subnet.
Yeah, and this is live, folks.
So we have 10.10.0.0/16. So 10.10.1.0/24. There we go.
Yeah, there you go.
Yeah.
You could, yeah.
Yeah, I just wasn't thinking that through.
Oh, yeah, that makes sense.
Yeah.
Of
Yeah.
course that makes sense. Yeah.
Yeah.
Now.
Yeah. All right.
Oh.
So we're creating our network here.
Yep. Yeah, bigger, not smaller. All right. So while we're waiting for this to deploy, I have a question for you. Now,
Sure.
I have to admit that I have always assumed, and I found out that it's an incorrect assumption. I have always assumed that everybody on the planet toasts Pop-Tarts and puts butter on them.
I saw that. I have never heard of such a thing. I see that there's
I'm
actually a
stunned.
song about that. But
Yeah, I'm stunned,
I-
man. I just thought that was normal. I grew up doing it. I thought it was normal. I mentioned it to somebody the other day like it was matter of fact, and they looked at me like I was just nuts. And I'm like, well, what do you mean?
toasted Pop-Tarts are delicious.
like,
So
That's
I mean,
that's
butter's
gross. I'm
good.
like, how
Yeah.
is it gross? They said, oh, I've never, it just seems gross. And I'm okay. So not a cold pop. Don't start with a cold Pop-Tart and put a cold butter pat on it and eat it. That's not what we're talking about. We're
Talk about
talking
eating it and then putting it and then applying
yeah,
butter.
yeah. You toast the Pop-Tart, then you put butter on the Pop-Tart. I mean, it's
It
delicious.
honestly sounds amazing. You've got the heated Pop-Tart. The Pop-Tart is going to absorb the butter. I mean, it sounds delicious.
Man, it's the best thing on the planet. I love it. But the same person that said, "Oh, it's gross," I said, "Well, do you like Cinnabon?" "Oh, I love Cinnabon." I mean, give me a break. It's pastry, cinnamon, sugar, and butter. It's the same thing.
Wrong? Yeah.
How can you go wrong? Amazing. Just amazing.
Absolutely.
All right, so we're gonna stick the second subnet in a different location.
Yeah, I'll go ahead and put it in South Central US.
Okay.
Whoops, I didn't mean to hit create. I got to hit IP addresses.
Yep.
All right. Actually, this is actually an entirely different network range. So this actually we can, if we roll with this, so we've got a 10 dot and a 172 dot, and we can string them together. So
but I want to make sure everybody understands what we're doing, because what we did before was a little different.
Yeah. That we did
I think you did .1.0, didn't you?
That was my subnet. I'm trying to remember the
Yeah. Oh, we're creating another network.
Yes.
Oh, another network. Okay. Yeah. So
10.10. Did we have 3 10s or
it was
a /16?
Yeah, it was a /16. So do a 10.9.
Yep. That's what I was trying to remember what octet we were working with. Okay. So we do that, and then we'll add a subnet.
Why are we getting that virtual network? Oh, you've got another virtual network that.
Yeah, but in Azure, because they're all software defined, it's just warning me that I'm not going to be able to put those two together.
Yeah. So, yeah. No worries. That's good to know in case anybody else sees it.
Yeah, exactly. /24. Okay. Let that do its thing. And if I go to our resource.
So to be clear, just so that, again, if anybody is confused, what we started with was a diagram that showed 2 subnets in the same network. And what we're actually creating is a little bit different than that. What we're creating here is 2 networks with a single subnet in each network.
Correct. Yep.
And the reason we're doing that, just so that everybody understands, the reason that we're doing that is because we wanted to show, and we decided on this design path after we started the podcast. We wanted to show that you could have networks in completely different regions, and that the access between those networks in the Azure environment was exactly the same speed as
Correct.
having two subnets in the same network in the same region.
Yeah, I mean, it might be a little faster in the same region, but because I mean, you got speed of light, and you know, because we don't actually advertise it, I'm sure that if we had, you know, thousands or maybe, you know, hundreds of thousands of customers trying to access resources in another region, I'm sure at some point there's going to be some sort of throttles that are going to kick in, but it's certainly much greater bandwidth that is available than say, you know, an IPsec tunnel between them.
Right.
And it's much less costly because, you know, IPsec tunnel, regardless of what direction you're going to go, there's a cost, whether you have a virtual appliance from Cisco, Palo, or Barracuda, you know, not to downplay any of our partners, because those have perfectly valid reasons why customers use those. But there's licensing costs, and there's infrastructure that needs to run in Azure to support that. When you have everything in Azure and you just want to plumb them together, the you know, network peering capability is so much easier to set up.
Yep. Yeah, makes sense.
Yeah, so we have these two networks, and so if I go to the east, so we don't have anything deployed in these networks yet, and I can see that, you know, by going to connected devices here, and what we're going to do is set up what's called VNet peering.
Okay.
So we're going to set up a connection from the east to south, and what I'm going to do is Skynet East, taste, there it is, right there. So this is east to south, and then south to east.
Okay.
All right, so then we have some options here where we can enable what direction we actually want traffic to be permitted to flow, to go from east to south, and then conversely, this is actually setting up the other direction to allow it to go from south to east. So, you know, depending on what this is actually going to do is deposit all of our routing rules and set up our network security groups to be able to allow this connectivity to work.
Okay, so you had to essentially set up two single direction connections.
Correct.
One
yep.
east to south, and then one south to east.
Right. So if you think about that, like if you're building a mesh network, and I actually have an example of that we can look at, where I have a network in west, and I have one in east, and I have one in north central and south central, and to be able to allow traffic to go, so I could just have like north central go to east, and then have, you know, south central go to or sorry, east go to south central. But if I wanted my network in north to be able to talk to both of them, I have to create peered links to both.
Yeah.
So it's kind of a so, you know, you could end up with a lot of peers if you have a very big meshed network.
Okay, so hang on just a second. I just
Yep.
want to draw this out for everybody.
Mhm.
I'm going to share MS Paint, and I'm certainly not an artist here, so this is not going to be pretty. I'm just letting you guys know up front. Hang on just a second. All right. Okay, can you see Paint?
Coolest tool ever. Yep.
Yeah, can you see it? Okay, so that's
Yep.
one.
Mhm.
These aren't going to be symmetrical. Sorry about that. That's two. All right, so this is going to be network A, right? And in here we have a subnet. Okay, and then this is going to be network B.
Yep.
And then we have a subnet. Hang on. Okay, and this is in the east region. Okay, and then this is in the south region. Okay, and then we just essentially are creating two connections.
Correct.
One that goes east to south. So I'm going to say east to south.
Got it.
And I'll just do a little arrow there. Okay, and then we're going to draw another one here. And this one goes south to east. Like that.
Mm-hmm.
Does that make sense?
You got it.
Okay.
That's
All
what we're
right.
doing.
So I'm drawing this out for everybody here so that they understand what we're doing. Now, what was it called when we created these links? What was the official Azure name of that?
So it's called VNet Peering.
Yeah. VNet Peering. There we go.
All right.
Okay, so there we go. So that's what we're doing, folks. All right, so I'm gonna stop sharing my screen here.
All right.
Or stop sharing the app. Hang on. There we go. Okay. So
right.
we should be. Can you still see the app, or can you see me?
I can see you, and I should be sharing.
Okay.
Yep.
Okay, so we're in good shape. Okay, continue on. I just wanted to make sure that we had it mapped out.
Yep. So there's some other options here that you can see that allows you to accept or allow forwarded traffic to go over that link. So if you had some sort of virtualized NAT appliance that's sitting in maybe the south network is receiving traffic from outside the south network that's destined for an endpoint that's in the east network, that traffic is going to be known as originating within our software-defined network from a different network. So you can actually have control, the ability to control whether or not you want to allow that traffic to traverse.
Yeah.
The final option is this gateway transit checkbox. And it's going to yell at me because I don't actually have a VPN. I don't have a VPN gateway or an express route gateway. And what that means, like if you have a hub and spoke network where you have maybe the hub network that's got all your security stuff in it, directory controllers, maybe all your core network infrastructure, and it's connected back on-prem using a VPN connection or an express route connection, whether or not it's going to allow traffic to go over, I think it's two-way even, if I'm not mistaken, for cross, can have a gateway. Yeah, so I'm pretty sure it's multi-directional, that where it allows, Azure's going to know, via routes that I set up about the network on-prem and how to get to it using that, that VPN tunnel. And likewise, my on-premises network, depending on how I advertise it to my on-prem network, is going to know about all the resources in Azure. So this allows me to allow traffic that hits, let's say my south network has a VPN network in it. This allows traffic coming into my south network to go to my east network that's coming in over that VPN tunnel. That's what that checkbox does.
Okay. All right, that makes sense.
Yeah. So if I hit OK, now it's adding the peered links here for both sides, and it takes just a moment to enable.
Okay.
There we go. So you can see I'm looking at the east, and it's showing east is connected to south. And if I go to my south network, which I want to click on that, it takes me over to the south. And I go to peerings, it did the reverse on the other one where it goes south going over to east. So there's
so now they're both connected.
Correct. Yep.
Now, if one of them was not connected, we could send traffic one way, but not bidirectional. So we wouldn't be able to do things like establish TCP sessions, or would we?
That's I don't know. In terms of ephemeral ports.
Well, so a TCP session requires
Right.
bidirectional communication.
Correct. Yep.
So the question is, if I have link A set up, I could maybe send a SYN request to a target that's in the other environment.
Correct. Yeah.
But I wouldn't be able to get the ACK-SYN back. Is that what we're saying?
Yes, that would be the technically what we're disallowing.
Okay.
And there's another, so you have to opt in. It used to be that there was that you had to actually go in and approve it. So we've changed what that user experience is. I have permission to be able to create this endpoint on both networks. Now, what would be more typical, like let's say that I'm a developer at a enterprise customer, or building a line of business application, and I want to plumb in my application sitting in a network in Azure to core services that IT manages.
Okay.
I don't have permission, or I probably wouldn't have permission to enable that on the other network. So but because I have permission on both sides, I'm able to do that. It used to be. Yeah.
I guess the only question that I have is,
Mhm.
why wouldn't we just make it automatic? And the only answer that I can think of is that maybe we want to control the direction that traffic routes through, but it seems like we could automatically make an asymmetric route here if we weren't careful. And there's nothing wrong with that from a TCP standpoint, except that if there's firewalls in network A and firewalls in one of the other networks, they're not going to know anything about that TCP session setup, and so that could cause us to drop traffic, et cetera.
Yeah, I think it's more just for the approval scenario where I could create the peer to the hub network, but I might not have permission to actually create the corresponding peer in the other network, and I'm going to need somebody who actually does have access to say, okay, I trust your network, and I'm not just going to let you attach to me without me knowing. So I think it's more for that scenario where if I didn't have the permission, then I'd have to actually have somebody else create this other link for me.
Okay, but definitely the bottom line is we have to do it bidirect. We have to set up both to communicate.
For that traffic. Yeah, exactly.
Okay, all right.
And like I said, it used to be that you would do both of these steps separately, and you would actually have to go into each of them and say, I approve this, I approve this. So it was a handshake, and it looks like that, because I have permission in both, that the user interface says, I need to do this to make it work, and you have permission to do it, so I'm going to do both sides.
Yeah. Okay.
So for all intents and purposes, if we put stuff in one of those networks, we'd actually be able to, to make them talk. And I guess we could actually go in here and maybe deploy just a real simple VM. I can put a Linux box.
Yeah.
Okay, so we'll just call it East VM, and I'll put it in East US, and that seems fine. Put in a super secret password. It's going to allow connectivity to it externally, and I'm going to go to networking. And see, because I picked East, it's going to default to the first network it found in East. It's going to land it in that subnet A, and it's going to allow traffic to port 22. So everything looks good on this. So I'm just going to go ahead and let it create this guy. And while it creates this VM, I can create one in the south.
Okay, that sounds great.
Let me go ahead and do that. And I'll go and create another one here. And we'll call this T South, and keep everything else the same. Do password. My fancy mechanical keyboard here. You can hear me go clickety clack on.
That's awesome.
Yeah,
that's the way it should be.
Okay, so this is going to put in the south, and everything's the same. So pretty basic, just creating two simple VMs.
That's just, that's something that I just assume is normal. Kind of like, butter on Pop-Tarts.
Absolutely. Which I have to try, when we
Man, I can't
actually
believe
get out
it.
of this quarantine and get out to the grocery store.
I really can't believe it. So I'll tell you what started this. And for the folks that are watching this, I didn't want to say anything because I don't want this to be dated, right? But right now we're in the coronavirus quarantine, and
Yeah.
so here's what started the Pop-Tart thing. I went to our grocery store, and I was looking for TP, and there was no toilet paper, and so then I said, oh, that's okay. I'll just
What it
go
is
grab
with
some.
people with
Yeah,
TP.
yeah. I don't know, man. I don't know. You know what? I need some food too, so I went
Yeah.
over to the breakfast aisle and I was looking, for some cereal. My wife is, she can't have gluten, so I usually get like Rice Krispies or something
Yeah.
rice based because it's usually gluten free. And I noticed that all of the Pop-Tarts were sold out. And at first I'm thinking, well, why would people be buying out Pop-Tarts? But then it hit me. Shelf life, right? Pop-Tarts
Yeah,
last
that's true.
forever. Yeah.
Should
So
buy some Tang too.
yeah, that's right. So all the preppers, I guess, are buying toilet paper and Pop-Tarts. And so that started the whole Pop-Tart conversation. But
That's funny.
pretty funny. Yeah.
Yeah, it is. So what I just did, so one of the machines just came up. So I just kind of got stuff squared away so I could kind of walk through the steps here. So I made these machines have public IP addresses. Is probably atypical from a corporate or line of business or enterprise type application or networking environment. But we cheated for the sake of simplicity to allow me to easily get into that machine.
Yeah.
So going to go ahead and if I do, so I'm hitting the public endpoint, and in Azure, we don't actually assign that public IP address to the network interface. It's we do network address translation. So if I look at my network interface, you can see that this is the IP address that it has, and nowhere do we see reference to the public IP address that this machine actually got.
Right.
So this
Okay.
is VM1, and this is the one that is in the east. And what I'm going to do, and I can see the private IP address, which corresponds to what I saw in the other window. And the other machine, I think, came up. So if I go to that, I made that one also have a public IP address, but it also has a private IP address. And I'm going to, instead of going, so I'm in the east, the machine in the east, so I'm going to connect to the one in the south via its private IP address, because now I'm going to use that tunnel that we made.
Okay.
So if I do this, and there is the private IP, and lo and behold, we're talking. So, and if I do, so this is, you can see my host name will change from East VM to South. So, and on here, you can see that it's got the 10.914 address that corresponds to what we see in the portal.
Yep. Perfect.
So yeah, bidirectional communication, we're going both ways. We can talk, and at a very high rate of speed. No IPsec tunnels. Very secure from a customer standpoint, because we're isolating all that traffic from customer to customer. It is not encrypted when it leaves our data center. So some customers, that might be a requirement, but we do. And that's where the advent of things from our partners like Palo Alto devices and so forth come into play, where you can actually encrypt that traffic if it's necessary.
Okay. So we've created. So I'm just going back to the drawing.
Yep.
So we've created two boxes, one in each subnet.
Yep. You got it.
Okay. And they can talk to each other. We've just proven that over the peering, the VPN peering that we did.
Correct.
in Azure. Right?
Yep.
So all good?
Absolutely. So way easier than, like I said, setting up VPN tunnels and dealing with keys and all that other sort of stuff.
Okay. All right.
Yep.
So let's share your screen again.
Sure.
Let's go back. I can just hit the, there we go. There we go. Okay.
So the next step, so now in your diagram you showed at the beginning, the leg of the T that you drew was connectivity from on premises into Azure. And
right.
so the way that you can facilitate that, and I have basically what we just built already in place with a what we call a virtual network gateway that's created, and I'll show you. If I go to this,
So
go back to, yeah.
So hang on just a
Sure.
second. Sorry to interrupt you.
Mhm.
But here's what I'm thinking. Let's make this 2 parts, and we'll make this what we've done right now, because we've set up all the Azure components for building the environment up. That's all up.
Correct.
Right?
Yep. Mhm.
So I'm going to break this up into part 2, because I think part 2 we're gonna create the VPN gateway to our local network. Correct?
Sure. Yep.
All right. So thanks for helping me out with part 1. Stay on the
Sure, yeah.
phone, and we'll start part 2.
Right. Sounds like a plan.
All right. Hang on a second.